All right, so yesterday I showed you how to do this without doing it mentally, right? You could do it by hand now. So who can tell me what to type in the calculator for the one on the left? I'll put it over here. I can put it right in the middle here. Anybody? Nobody's helped me out today? What do I type in for the one on the left? Just like it is, right? Because this has no base. What is the base? 10. It's that one. That's the common log, right? So I can just put 4 log 1,000, which is 12, right? So that one's really easy because it's the common log, right? What about the one on the right? What am I going to have to do? Since it's a base 13. What did I show you yesterday? Change the base formula. Is it log 13 over or is it log cube root of 169 over? Which one's on top? The cube root one, right? The base goes where, did I say yesterday? The basement, right? So I wouldn't worry about the 5 yet. I would just put this in and then times 5 when I'm done. So you get log, and then you got cube root at your math number 4, I think. Like that. Close it off, and then log a 13 in the bottom. That's how I put in my calculator. Okay, that's that change of base where we don't have to do it mentally like we did the night before. Okay, so I'm going to do that. Log, cube root again is math. The 4th one, that's 169. Now, in this cube root had a parenthesis. So for the cube root, I had to close off the parenthesis. And for the log, you got to close off the parenthesis. So that one had a double parenthesis on the end, right? And you have to close off the parentheses on these so it'll, figure it out the way it's supposed to. And then hit log of 13. Close it off. It gives us that number. Okay, but that doesn't seem right though.
You forgot to divide.
Oh, exactly. Thank you. So don't just put time. I did times instead of divide. All right. So I'm going to hit second enter. It's going to redo it. And I'm going to try to insert a division symbol in. But you could just retype it too. I think I need to do it there. Yeah. There we go. That's more like it. And then remember, this 5 was out front. That means 5 times that. So then I'm going to hit times 5, just so I don't have to type it in the beginning and make sure. So you can leave it 3.3 repeating, or if you want to write it as a fraction, hit math and enter twice, and it's 10/3. Either one is acceptable. I just wanted to go over that again with you, how we can put it in the calculator using that change of base formula. All right, so we good on that? Any questions? So just remember to close off your parentheses when you're doing your logs. Okay, so today we're going to go over some properties or rules for these logarithms, which again, logarithms are exponents, right? So basically all it is our exponent rules, okay? But we'll review them. All right, so the property product, again, when we had exponents, if I had the same base, like b, like 2 squared times 2 cubed, That's 2 to the 5th. I just add the exponents, and then I can do the problem. Okay? Well, the same thing is true for logarithms, okay? If I have log of 2 things that are being multiplied, I can separate it into 2 separate logs and add them. All right? So we're going to do something called expanding logarithms today and condensing logarithms. Okay? So when we expand it, we're going to turn it in from 1 log to multiple logs. Okay? If we have multiple logs and we want to condense it into a single log, we're going to go the other way. So if we have addition, if we have 2 logs with the same base, and they'll have the same base, and I'm adding them, I can condense it down and make it a single log with the same base and multiply those 2 things. Okay, so we're going to go back and forth. So when you see multiplication of things and you want to expand it, we're going to turn it into addition. If we see addition of logs and we want to condense them into a single log, we're going to multiply them. Okay? And again, the bases will be the same. Base 3 or base 5, or it might be a regular log or a natural log. Okay? What's the base for a natural log again? E, right? Okay? This is also true for the quotient property. Quotient means divide. All right? If it'll go. There we go. Why is it not moving for me? There we go. So if we have division in a log problem, I can expand it and make it 2 logs and do subtraction. Okay? If I have 2 logs and I'm subtracting them and I want to condense it to a single log, then I can divide them. All right? So for multiplication, if we're expanding, we're going to turn it into addition. If we're condensing, we're going to turn it into multiplication. For division, if we're expanding, we're going to subtract them. If we're subtracting and we're going to condense them, we're going to turn it into division. All right? Or write it as a fraction. Because that's what a fraction is. It's a division part. Okay? They got to have the same base. Right? We couldn't add this 5 and 3 because those are different bases. That's a base of A. That's a base of B. Right? And these will have the same base, the ones we're doing. Okay? So those are just properties of logs that work. Here's another one that we'll use. Okay? If you have a log of a number to a power, okay, you could do it this way, right? 10 cubed means 10 times 10 times 10, so we could make it into 3 separate addition of those 3 logs. Or you can take this exponent and move it out front of the log and multiply it by the log. All right, so if you got a log base b of a to the p power, you can move that p, that exponent, out front and multiply it by the log. We will do that when we expand. Okay? All right? If we have a logarithmic problem that's expanded and we want to condense it, and we have a number out front of a log, we're going to move it to the exponent. Okay? And we did this last year, but we only spent a couple days on it, so good. So, all right, if you have 2 logs with the same base that are equal, all right, that means that this m and n value would be equal. All right, you'll probably see it this way more than any. Okay, if you have to solve a logarithmic problem and they both have log with the same base, then whatever comes after the 2 logs got to be equal. So we usually just drop the logs in a problem like this and set those, whatever comes after, equal to each other and solve it. Okay, which makes sense, right? There's the same log on both sides, drop the logs. Change of base formula, we did that yesterday, so that's nothing new. I had that yesterday instead of today. Okay, so here's the type of problem. Here's a single log. I want you to expand it. Okay, since it's got two variables, we're going to expand it into two separate logs. Okay, so from our rules, we went over here just real quick. Since this is multiplication here, I can split these up into two logs by doing what? Adding or dividing? Subtracting? Adding, right? Multiplication, you turn to addition. So we're going to go log base 5 of x plus log base 5 of y squared. Okay? Now, when you expand logs, you don't want any exponents. You don't want any radicals. Okay? So what you got to do is that third property we talked about. If I have an exponent here, I can move it out front of the log. Okay, so to get this expanded completely, I'm going to move that 2 out front. So you want nothing but a variable here. Any exponents you turn into a number or like a coefficient in front of your log to expand it. And that's as far as we can go. Now, sometimes when you do this, when you get a single log here, you might be able to simplify it. Like sometimes you might get log base 5 of 5. What did we learn log base 5 of 5 was? 1, right? So we would simplify it to a 1. It's got a variable, you can't simplify it. But if it's log base 5 of 5 or log base 5 of 1, what's that answer? 0, right? Remember when the 1 comes after our log, the answer is 0, so we could simplify. Things like that. So basically that was a two-step thing. We broke it up or expanded it into two logs because we had two variables by addition because that was multiplication. And then since we had an exponent, we moved the exponent out front. So when it's expanded, no exponents. When it's condensed, you can have exponents, you can have radicals, that kind of stuff. All right. Let's look at another one. I think I have another one down here. Yeah. All right, now I have 3 variables. So I'm going to expand it into 3 different logs. Okay? Since it's natural log, that's what I'm going to use for my base. All right, I'm just going to use ln. So this will be natural log of e with multiplication. I put plus natural log square root of y. Since that's division, I'm going to go minus natural log of z cubed. So with multiplication, I turn to addition, and division, I turn to subtraction. Now, you're not supposed to, when you're expanding, you're not supposed to have any variables. I'm sorry, not variables, any exponents or radicals signs, okay? So, I'm just going to write this with an exponent. What's the exponent for square root? We talked about this the last couple days. 1/2. Yes, thank you. I'm just going to write it like this again right now. So I turn the radical to an exponent. Now, what do I do with these 2 exponents to finish up? I'm going to move them out front so they're not there. Okay? Now, is that as simple as we can make it? What do you think?
Yeah.
Yes and no. What's the natural log of e? 1. Yeah. Remember, what's the base for natural log? E. So this is like log base e of e. which means 1. So actually we should write this as a 1 plus 1/2 natural log of y minus 3 natural log of z. Okay, so that's every now and then you'll get one of these logs that you wrote, something you can simplify. Okay? That's expanding. So however many variables you have, that's how many you expand it to. Does that make sense? Multiplication, we turn to addition. Division, we turn to subtraction. And the exponents we put out front. If we got radicals, we use the exponent. 1/2, or for cube root, we use what? 1/3, okay? So whatever the root is, whatever the index is there, we make it 1 over that, okay? So far, so good? All right, now we're going to go the other way. We're going to get something like this. 2 or 3, 4 terms. We're going to condense it into a single log. All right? So, I've got 2 logs here, right? So I'm going to turn it into a single log. The first thing I do is when I see numbers out front, I'm going to move them into the exponent area first. So, natural log of x squared plus natural log of x plus 4 to the 1/2. Now, since it's addition, to turn that into a single log, what would I do with the x squared and the x plus 4 to the 1/2 power? Multiply, right. Now, what they like us to do when we condense, instead of having a fractional exponent, they'd rather us write what? What's the radical for that? Square root, yeah. So that's been condensed to a single log. Again, if that was 1/3 there, then this would be cube root of x plus 4. So any numbers out front, we put it as the exponent. Addition, we're going to end up multiplying. If that was subtraction, we would have ended up writing it as a division or a fraction. Okay? This making sense? We good on that one? Let's do another one. So I got 3 this time. All right? So the first thing I'm going to do is move this 3 here and put it the exponent for the y. So I'm just going to do one step at a time. Some of you can kind of look at this and tell me what the single log is. That already had the 2 up there. All right, so when I start condensing this, what's going to happen with these 2? Multiply, but what am I going to do with this one? Divide, yeah. So it's going to be log base 5. Again, we use whatever it's always going to be the same when we do these. So just keep it the same. Don't switch it. And then it's just going to be x squared minus 4 times y cubed over x minus 2 squared. Now, what they want us to do when we get it as a single log like this, if we can simplify this fraction that we just made, we're supposed to do that. Is it possible to simplify that fraction? Yeah, it is. What do I got to do to be able to simplify it? Yeah, we got to factor that's x squared minus 4. So if I rewrite this factored, this would be x plus 2 and x minus 2, the y cubed, and this would be x minus 2 times x minus 2. You guys with me on that? So I factored the x squared minus 4, and I just wrote x minus 2 twice. That's what x minus 2 squared means, right? Now, are there any factors I can cancel? Yeah, there's a set of x minus 2's, right? So my final answer, to get full credit on something like that, would be log base 5, and then x plus 2, the y cubed, and then the x minus 2. So sometimes when we condense, we get it all condensed, there's a fraction there that we can simplify. Okay, so addition, we turn into multiplication. Subtraction, we turn into division. When we condense, any numbers out front, we turn into exponents. Okay, if we have fractional exponents, then we turn them into radicals when we're condensing. Making sense? Okay. I don't think I have any more examples. Let me see. Oh, I do. Let's do those two real quick on your calculator. Then we'll check. Check them here. Just for more practice on that change of base. Do the second one. Do the second one. Yeah. Close it. Log All right, so hopefully you typed it in correctly, but this is what should be typed in. Log of 18, close it off, divided by log of 3, close it off. Remember, the base is 3, goes in the basement of your fraction, right? Over here, log of 400 divided by log of 12. Okay? Easy problems, right? We shouldn't be missing those when we actually get to our quiz, right? So we get 2.63. You guys okay with that? Everybody good? And then log of 400. Actually, let me show you this. All right, you could do natural log if you wanted. It'll still work. Just make sure you do the other one as natural log. Let's see if I'm right. Did you guys get 2.41? You should have. Okay, so if you hit the wrong log button, it's okay. Just be consistent. You can hit log or natural log. Okay? Any questions? Okay, so I thought today I'd give you the night off, no homework, and then the homework for this we'll do in class tomorrow for a class assignment, and then you won't have any homework over the long weekend. How's that sound? Is that okay with you guys? Okay.